Morning, everyone. Welcome to our fourth and final day of our Introduction to Deep Energy Retrofits webinar series. Today, we're joined by project collaborators Tyler Hermanson from 4 Elements Integrated Design, as well as Steve Norris here beside me from Steve Norris and Partners Building. So today, we're going to go through some retrofit case studies that were done in the Calgary area. And we're also funded through SAIT, our project funder in this case. So I'm going to pass it over to Tyler, and he's going to go through the first couple of case studies. We'll have a small break, and then Steve will go through his actual house and his primary case study. And then we'll have ideally, there's some time at the end for some proper Q&A and maybe a roundtable discussion. With that, let's get started, and I'll pass it over to Tyler.
Thanks, Dean. I think you'll have to advance the slides. So in our project of assessing these houses, 3 were chosen. Project 1 here is my house. It was originally built in 1954, fully developed basement, and my family added a loft, kind of second floor, in 2000. This house has been in our family a long time. My dad bought it in 2000. We had lived here for a long time, and we've been renovating it again and again through the years. We're serial renovators. And the goal here was to kind of go that final leg to see if we could get the final phase done to get this into net zero type territory. But what we found was this house is very complicated. You can go ahead. And we also had the smallest budget out of all the projects in our study. When we did our integrated design kind of planning session at the outset, we knew that we had from living in the house some real comfort durability problems. Previous renovation had redone the mechanical system and fully developed and super insulated triple glazed windows in the basement, and so we had this lovely comfortable basement suite. It was working really well, but upstairs we still had frost building up on our baseboards. And one winter the kids' stuffy got frozen to the wall. There was so much thermal bridging through our uninsulated, barely insulated walls. So we knew we had some problems there. We knew we had some high air leakage, and we'd just been so busy since 2013, you hadn't been able to do the next reno. So this was hoping that we could kind of get all the way there. We registered the LEED project with the last reno, following the LEED program, LEED for Homes, in our choices on indoor air quality or landscaping choices and things like that. But we couldn't get our efficiency up high enough to meet the EA section in LEED. So this was also a chance to see if we could hit that target. We also had some miscellaneous stuff to do. I think in a lot of these renos, there's a non-energy related, a usefulness driver to the reno as well. We are short on storage. We had a failing old shed in the corner. This was a chance to fix that just functionality problem, right? And these rentals always have some type of functional driver as well. And the original planning, we realized very quickly that we weren't going to need a DP for what we had proposed. We weren't changing any window locations. We weren't adding any square footage. So from a permit process, nice and smooth, and away we go. So the original house in 2000, when we renovated it then, my dad and I added 1.5 inches of XPS insulation to the main floor walls, trying to improve those uninsulated walls. And we thought we were doing pretty good in 2000, the improvement in comfort, the energy savings, new windows, and then, but 23 years later, that still wasn't enough. We hadn't got the air tightness under control. We'd learned a lot more about building science and the needs of energy efficiency in the intervening years. So we really had to push further, but that affected the eave line of the house because this house was originally built with no eaves. Um, it was a manufactured home built just 5 blocks away in 1954 in an industrial area just south of us, and driven to the site. So it had some unique architecture to make it easy to move. Um, so we reached out to Owens Corning and learned about their new XPS product that has a very low global warming potential. It actually brought this XPS into kind of our sustainability goals. It didn't really have that much more embodied carbon equivalent than other products we were looking at with the other projects, mineral fiber, EPS insulation. So whereas when we did the math, our original 1.5 inches of insulation had just barely uh, paid back its carbon debt from when it was installed in 2000, because those older recipes of foam were really high global warming potential blowing agents. So we didn't want to take that foam off, right? It's still insulating, it's still doing its job, and it had just paid back its carbon debt from when we installed it 20 years ago. So let's leave it in place. And so then it made sense to add more foam to that wall to bring it up to the R value we need and get the air tightness this time that we wanted, using Owens Corning's codeboard approach, where you use a flexible tape to seal the XPS and move your air barrier to the outside plane of the wall. So we got lots of photos kind of show how that works. So we wanted to get the insulation quite a bit higher. In our math, that our high 20s, low 30s is a great, sweet spot for insulation. That had the least amount of effect on our roof lines. Obviously allowed us to stay in the home during the reno. That's really important in all the renos we looked at. And it was a chance to address some thermal bridging at our concrete foundation as well. The windows that we had redone in 2000 were at end of life. We had noticed the seals were starting to go, they weren't closing properly. These were wood clad aluminum windows. And through the renovation, we actually found that some of them had actually started leaking water into the rough opening and causing damage. So the timing was perfect. It was just lucky that we were able to do this reno now, because we hadn't even noticed that damage happening yet. But the whole sill of one window had to be replaced. We'll talk about in a minute. And another plan for this project was really making sure that we were future ready for electrification, that we could add EVs and solar in the future. And we had a fairly tight electrical system already that had been added on and renovated many times. So electrical was something that we had to carefully assess. We wanted to move the electrical meter out of the backyard where it's kind of in the way. So this was a chance to get a new meter, upgrade our service, and plan for that future piece. Upstairs on the main floor and upper floor, we didn't have an HRV. So this was a chance to improve ventilation. The bathroom didn't have ventilation, mechanical ventilation, just had an opening window. That's not good enough for LEED for home. So this was a chance to put some HRV exhaust into the bathroom upstairs and fix a few things there for air quality. And then get ready for future solar. So we were starting with quite a bit of natural gas consumption and high heating demand still. The walls weren't that insulated. So that's where we made our big impacts. And we really noticed that in comfort. The temperature is much more even, and the house doesn't feel as cold now with that air leakage improved and the walls and windows better insulated. We made a big improvement to air tightness, but we couldn't get this house all the way down because we didn't do the roof. The ceiling, the concrete roof tiles are not at end of life. We didn't have it in the budget to take them off, super insulate the attic roof area as well, and then put those tiles back or something like that. So we kind of made the gut decision, middle of the reno, that we were going to have to leave the roof for a third phase of the reno. We couldn't do it in the one shot that we wanted. And that's just the reality when you run up against limited funds and timelines and the pressures of the projects are always under. You can go ahead to next slide. So the interesting thing in this project is we know what the house was like in 1950. You see what the house was in 2013. And before we started the reno, so we know the history of this house for quite a while. Um, in 1950, it would have had an uninsulated basement, aluminum slider windows, and uninsulated main walls. And then we improved it, changed the mechanical system in 2013, improved the basement, but still a lot of work to do. We had vinyl siding on this house that wasn't that old, but was the sacrificial piece. You had to get rid of it in order to insulate. This was a chance to go to more durable siding, we realized as well. But you can see those narrow eaves became a problem. So here's the original enter guide, 133 gigajoules per year, put us worse than today's building code. Not the worst house on the block. Certainly, we had made good improvements over time. This house originally would have used 300, 400 gigajoules a year when you looked at how it was originally built. But that's improved over time, and this is just a continuation of that. You can see most of that energy is used in space heating, which is pretty typical. Go ahead. So here's taking off the siding and starting to look at the assessment. You can see lots of different foams as we did different parts of the renovation. We had tried to improve the air tightness when the siding was changed 10 years ago, but the trades didn't do a good job, didn't work. And so some of that stuff had to be taken off. Siding turned out not to be very well attached. We didn't realize that they hadn't nailed it very often, and the siding came off in huge sheets. But the foam underneath was still in good shape, and obviously still insulating, still doing its job as insulation, so it stays in place. You can go ahead. So you start to see where we had to extend the roof line to prepare for that extra insulation. It turned out not to be too hard because we could keep the roof tiles. That's one of the benefits of concrete roof tiles. You can take them off and put them back again quite easily, it turned out. There's a bit of extra labor there. We were able to reintegrate it into the waterproofing layers. In the middle picture there, you can see how things had aged over the last 20 years. Weather stripping had already been replaced once, but it failed quite quickly again. These were aluminum clad windows made here in Calgary. Not the highest performance windows compared to what we can get now. And those wood windows move a little bit. They don't have the best gaskets when they were installed 20 years ago. So air leakage around the windows was a real problem. And we found one spot where during the last reno, birds had gotten into a gap in our siding. We hadn't come back to finish because we knew this next reno was coming up quicker. 10 years goes by real fast though. So we had to clean that out. We found a hornet's nest in one of the rim joists. We found, lots of interesting things when you tear apart a house. You can go ahead. So here we're installing the new insulation. So it was quite easy to frame out around the windows to create a new support structure for the windows because we actually moved the windows outward, give us more space on the inside. We wanted those nice deep windowsills, and it made for an easier waterproofing line because really our water barrier, our air barrier was moved to the outside face of the foam. And so the tape that we used was really important. And you do use a lot of tape. You tape all the seams, you tape all the rough openings, and you're really using that as your primary water barrier, and you can't let any water get behind it. That creates some awkward little areas where roof intersects and walls intersect different ways. This is a complicated architectural house, lots of changes we've made over time, and that really made it not an ideal candidate for deep energy retrofit and drove up costs. And so complexity of the existing house is something now we would look really closely at with renovations. You see how the tape ties right into that rough opening, making that air tightness go all the way back to the original wall. Really important around the rough openings, as we seal the windows in. And here's the damage that we noticed just starting to form under one of the north-facing windows. So it's kind of your worst direction. It was a big casement window, no eave protection, and it just started to fail. That the wood aluminum windows don't last as long as vinyl and things like that. So water had been starting to get in at one of the mullions and damage the sill to the point that Corey had to rip it out. We weren't planning to do that work that day, but luckily the damage wasn't too bad. You could jump in, replace the sill, and not really hold up the flow of the day. It was winter by then, so we also had the added pressure of weather. Go ahead. So sealing the windows, once they were installed was really important to integrate it into this new barrier, the new foam barrier. So we use Baccarat and caulking, which is really your best method of installing windows, more than just using a bead of spray foam or something like that. The caulking provides a much more robust seal and was much solider. The windows are very well secured in that opening. The sealant really locks them in, and they're strapped with metal straps as well as the outside flanges. So they're really well secured. They're not moving. They're not going to move in those new openings. Yeah, go ahead. So as the windows get installed, we need to create the drainage plane for the siding and the support for the siding, because we knew at 3 inches of extra insulation, we're not going to have nails long enough to attach the siding right through the foam, right? You have to put strapping there. And so we chose to put the window in face of the strapping, so a really good drainage line happening behind the window opening, allowing lots of drainage if water ever got in. We want that free draining to that drainage plane, kick that water out and away. And then the strapping is there to make it easy to attach the siding without having to use long nails. And you can see on the corners how long that strapping needs to be, right? Because it needs to come all the way back to the original framing line so it can be secured and give the nailing surface right in the corner where the siding is going to go. So there's kind of an extra extension there of plywood, and gives the siders what they need to install the siding. So you can go ahead. Lots of little details to make the water deflection work, to make the air tightness work. And these things we found you really had to figure out as you went. The architectural kind of details, the planning that we had done didn't survive contact with the real conditions we found once you started opening things up. So the real importance of staying flexible and understanding the building science as you go through the reno. So you can make decisions as you go and adjust to the conditions that you find. And checking your work carefully. So we blower door tested this house before we put the siding on, because we knew as an exterior air barrier, this was our last chance to deal with some of the holes. And we found a couple missing tape seals or a gap here or there. It was easy to run around and seal those before the siding went on and really hid all of those air tightness details. That is one drawback of this approach, is your air barrier is buried by the siding later on. So if there's an error found at the final blower door test or a problem found, it can be very hard to get back to it necessarily to seal. All right, go ahead. One of the pieces, you can see the complexity of the tape seal, right? Because everything has to be sealed back to the original construction, back to the concrete at the bottom of the wall, back to the top plate at the top. And that was one air leakage weakness we found. We just, because we didn't take the roof off, we couldn't get as good an air seal at the top of the wall as some of the other projects were able to do. And that probably held our air leakage back quite a bit, just because we didn't have access. When you phase construction, maintaining access to the air barrier all the way around the house becomes a real challenge, because it may not fit within the scope. So thinking about how you're going to connect to that, really important, or come back and connect to that in the next phase. And so we have a plan in place for when those roof tiles do expire or get to end of life, how we'll replace them when we add the new insulation. Another thing we did preparing for the future in this house is install a chaseway that wraps around the house. It's that little plywood piece there. That helps us when we want to run additional electrical around the house someday, or if we're going to change where the solar panels go, as it connects right back to our meter base and then goes around 3 sides of the house. So very easily to pop that piece of trim off, run tech cable, run Wi-Fi, run whatever infrastructure we need in the future without disturbing the rest of the house or the envelope, right? Because this was all factored into the air sealing. Go ahead. So here you can see the new meter base and moving that electrical infrastructure around. Got it in a much better location, got the overhead lines out of the way for our backyard. Was a chance to future-proof for technology as well. So fiber, new internet was moved to this location, the secondary piece there. That could also be a good location for future solar runs down to the meter base, where there's now been installed an extra meter or extra breaker bay box where we have extra service and slots so that when we add an EV charger, when we add solar, we've got all the electrical capacity we need right there at the outside of the house. We don't have to do anything invasive on the inside of the house. So really thinking about how you're going to add this extra electrical load or manage it in the future while trying to avoid having to redo all your electrical work inside the house, because obviously that's a lot more expensive, a lot more invasive. And this external added breaker bay panel gave us that flexibility, worked really well. Go ahead. Did require a lot of chases and running armored cable around the house because you had to buy the service back to the original panel. It actually worked pretty well. We had an existing bulkhead to fit all the wiring in, very little damage inside. And we had this thick layer of foam that we could run things around. All those electrical penetrations had to be sealed at that exterior face because that was our air barrier here. But it made pretty simple air sealing details and seemed to work well. Next slide. As you button all that up, you want to put a smartboard trim behind, for a cleaner look, able to mount future things and have kind of a cleaner install. And that's a new bi-directional meter, so it replaced our old kind of analog meter. So we're ready for solar, and we upgraded to 200 amps. So we have the capacity now for electrification very easily. There's no cost for us to make that upgrade to 200 amps. In different projects, you might run into a big cost. So it's easy to do now, and it's something you should be assessed early on in your planning to see if that's a possibility. Because the alternative would have been load switch device, breaker boxes, more invasive, more expensive, but also would have allowed us to electrify. Go ahead. Lots of opportunities to provide air sealing. For air change reduction is still pretty good. We were pretty leaky to start with, and we found the chimney that was installed in the 2000 was not well sealed by the trades back then, and was an older style double wall B vent from the old mechanical system that was kept in place then. So this is an opportunity to seal that. Sure is awkward. And I'm not even sure with all the foam and all the detailing in there that we got all the little holes. I think these complex areas, when you have a reduced scope and you're not doing the roof from above, we're going to have to think really carefully about some of these details and how you get enough access to do the air sealing work. So this is almost, in my mind, a temporary fix because we know that we have to come back someday and do that roof, put in more air tightness, and put in more insulation to the roof structure. Go ahead. We had a very complex mechanical system for the second floor that was installed in 2000, and not with an eye at energy efficiency back then, right? This was before I was an energy advisor, before we had really started this type of stuff. And this is very typical for houses in the 90s and 2000. This was a great opportunity to fix all those mistakes. So this furnace came out with the new energy efficiency, and that we were able to just install a new duct run to provide heat up here and get rid of some of these huge air leaks that really made this space uncomfortable and loud, and not great building science here. So you're cleaning up a bunch of old mistakes, a bunch of old work. Go ahead. Little things as you detail the exterior, right? What about the water tap line? What about the exhausts for the existing boiler, high efficiency boiler? When you have an exterior air barrier, these tape details become really important. And that drainage plane gives you the water protection, peace of mind. You know that water can't be trapped in your wall. Everything will drain away. But that bug screen is needed because you don't want critters getting up in that cavity space. Thanks, Dean. Yeah, you can go ahead now. So this is a mechanical system we installed in 2013, and we didn't touch it in this reno. It's a high efficiency boiler using hydronics for baseboard heat in the basement and a fan coil on the main floor and second floor. It's been working really well. It gave us the flexibility for the secondary suite and a good energy efficient solution for the time based on natural gas. It didn't make sense in this reno to electrify now, but we're prepared for it because this hydronic system could easily be swapped over to an electric boiler. We're now looking at air to water heat pumps that are coming to the market, and maybe the boiler will get switched out with an air to water replacement when we electrify. So this type of hydronic approach gives a lot of flexibility because you can do a lot of different things with water. This one heat source is now doing our hot water for both suites as well as our space heating for both zones. That's a nice flexible approach, and knock on wood has been working well. Go ahead. And just as we started finishing up, there's a lot of little finishing details, as you put the roof back together and get the finishing, cladding, the fascia all done. And it's easy to underestimate how long some of that stuff takes getting ready to side and getting the house buttoned up. But it's getting close here. And then the siding starts. Go ahead. So very typical smart LP siding, so wood-based siding. A little bit of an upgrade from your vinyl. And the interesting thing is it was this change to wood siding, LP siding, that triggered the need for a building permit. When I called the city, like, hey, we're doing this deep energy retrofit. We're going to take the walls up to R30 and we're going to get ready for electrification and all this kind of stuff. They're like, oh yeah, you'll need electrical permit. Do I need a building permit? Oh no, that's fine. You're not changing any windows. You're not changing any structure. So no building permits required. And I'm like, oh, cool. And they say, well, I'm changing the siding from vinyl to wood fiber siding. They're like, oh, that definitely requires a permit. Oh yeah, you'll need a permit for that for sure. So it was interesting, the huge changes to the envelope, all that extra insulation, air sealing detail, flashings were going to be needed. They didn't think that needed a permit. The change of siding does trigger it. I think the city is going to learn, more about this, but the takeaway for us certainly is that you will almost always need a building permit in a deep energy retrofit. You're going to change something that is covered under the building code, and it may often be the siding type that triggers that. But it actually didn't slow us down. It provided a really strong, peace of mind, and it's not very expensive. So there's no reason not to go get a permit. We had a great supportive relationship with our building inspector and provided good oversight and checking our flashing details and things like that. And it really didn't cause any problems. You can go ahead. So I just starting to button up the siding. Kind of our final picture was taken just before not actually just before. It did take me a while to get around to the purging. But now we put in a reinforced purging across that exposed XPS on the bottom of the wall. Gives it, a kind of a standard concrete finish there. And last thing to do in the spring is the final paint of the trim and some little things like that. So they're always in a reno, you're going to have little things left. There's a lot of little things involved, but the house is comfortable and watertight now, and we have seen a huge difference. Go ahead. So in the final blower door, we got it down to 94. That brought it in better than code built house, which was a nice goal. It's certainly not within the net zero ready goals. We didn't bring the roof up to the insulation levels we were hoping to. We couldn't fit that in this reno. But we did make a serious dent in the amount of space heating that was needed. And we're seeing that energy improvement for sure. So about 39 gigajoules of energy saved, primarily in the natural gas, right? Our electrical loads didn't change very much. Cost for this reno, hard costs about 61,000. So this is a more affordable reno for sure. You limited your scope, so stay in our budget. Most of the costs were in the envelope, obviously. The walls take up the biggest chunk. That's the siding or the insulation and tape are not cheap. Although we did get Owens Corning to kick in the foam. That's about $10,000 worth of foam and tape, not reflected here, as they contributed to the Saria project. Windows are also an expensive part, not the windows themselves, but that install and the detailing and the trim, the painting the trim, and all those little things to finish getting the windows in, really does add up to a big chunk of the window budget line. And we made that more expensive by having such deep windowsills. That we realized that added a lot more paint and drywall, added more trim, and those costs really get slotted into the window package you see here. So those are big items in all the renos. Foundation and ventilation pieces, a little bit on electrical, moving that meter base around and preparing for electrification. Pretty typical costs here. Important to keep in mind, these costs don't include the contractor fee or GST, and that is a sizable chunk of the budget as well. And you want to factor that in, right? Because we had a hard cash stop where it doesn't matter if you're $1 over budget or $10,000 over budget. Money isn't there, the money isn't there. So watching the budget was really important to us, and we did well on that and worked really well. All right. Is there any questions here? So there's a question on the foam here. Worried about the vapor barrier on the inside of the wall and the double vapor barrier. I don't like the double bagging thing. We don't use that term here. But the building code accepts that walls will often have multiple vapor barrier materials in them. The code is really clear that you have to have one on the warmest side, and this house had poly as well as 50 years worth of 70 years worth of paint. So there was lots of vapor tightness on that inside surface. And because we had added so much foam, the inside sheeting was never going to get cold. There's enough insulation out there to keep it above the dew point, and meet the building code requirements for those other layers of vapor tight materials. So there's a degree of breathability. It's not a very breathable wall for sure. So that's why the water detailing has to be very good, and that drainage plane is very important for this type of vapor tight wall. But it works well and it meets all the building code requirements, and is just a different approach that still meets code. Yeah, you notice the mineral fiber there up on the second floor. Because that wall was added in 2000, it was 2x6 with R20 bats. So it was already quite a bit better than the main floor walls, even with that layer of foam we added. So it didn't need as much thickness to get it up to the R25, 27 range we were targeting. And the mineral fiber was a good option. It allowed us not to have to extend those eaves because it was a little thinner. And so it simplified construction a little bit and was a good trade-off. And that wall is a little bit more breathable. There's a house wrap air barrier behind that foam there, and that upper floor then it's to tie in and become airtight with the exterior side of the foam below in that one area. And when we do the roof someday, we'll have to tie back into that system as well, include continuity. The I might have good detail or picture of that transition, but you're watching that plane of air tightness kind of come around. And so the house wrap in that section was considered the air barrier and taped to the foam where we could, and has to wait for continuity with the roof membrane when that goes on someday down the road. Good question though. You caught that in the photo pretty quick. All right, on to the next one. So this is the second project in our study, not too far away from our house. It was built in 1957, so it's just slightly newer, a little bit bigger. This is a very typical 1950s split, where you've got a crawl space under the lower side of the house and a raised basement, a sunshine basement on the other side. Very popular housing type through the 50s and 60s. So you got a concrete basement wall, crawl space wall, and 2x4 construction with an insulated cavity. This by 57 insulation become more common. This was actually a more expensive house than mine was back in the day, and so it had some upgraded features, including R8 insulation in the walls, and aluminum slider windows and things like that maybe my house didn't have when it was built. Um, 1 second. Sorry, short pause. Um, uh, when we did the initial study of this house, we did get a high air leakage rate in the testing. Obviously, there was thermal issues and comfort issues in this house with its original original envelope that really hadn't been touched, right? There was very little renovation to this house over the years. Um, and it was time to replace the windows. Mechanical system had been replaced once, but was ready to be replaced again. Basically, it was kind of not the highest performance options. Um, so that really drove some of our decisions for super insulation and going to the net zero ready level. Go ahead. Um, Very typical for this for houses in Calgary. We've got had poor ventilation, had really no ventilation system, a poor functioning bath fan maybe. Um, Natural gas condensing furnace had been replaced, but never worked great. Might have been a little bit poorly sized for the replacement. And a gas hot water tank. And those don't have a long life anyway. So the systems was still operating. It wasn't an end of life, but we didn't feel bad about taking them out here either. And this house still had 100 amp service and an exterior meter. So we electrified um, this house as well because the main goal of the project was getting rid of the gas line. That was, we wanted to get to net zero ready, prepare for solar panels, and get rid of that gas connection. So that's a huge chunk of energy that goes away from the gas side, and you see that increase in the electrical load after the renovation was done. But it's still a much more efficient house after this work. 87% improvement in energy consumption in that air leakage. Huge improvement in air leakage through that. And this was solar ready. Again, in budget controls, as you start to run out of money, well, maybe we can wait for the solar panels. Where are we going to put the solar panels? Best was also a challenge on this site because we had some really big city trees in the front. And in our initial assessment, we thought they were going to be out of the way enough to make a viable solar envelope to make solar work on the main roof. Once we did the more detailed review with the solar installer closer to construction, we realized the shading was way worse than we had estimated. And there was a neighboring tree that we hadn't even really seen, a fir tree that was casting more shadows than we expected as well. So we really learned that getting the solar installer to do a proper assessment of the solar availability is really important early on because you're walking around the site, you're kind of imagining where the solar panels are going to go. It's hard to assess what the shading might be quantifiably, whereas the solar guys have tools, drones they can fly, models they can do, really understand what the potential solar generation is. In the end, we ended up planning for the solar panels to be on the garage and on the northeast roof, and still gives quite a bit of solar potential when they want to go ahead. And that city tree is at end of life. It could die in a snowstorm in a year. So you just kind of wait and see there as well. Those trees start to be taken out, then that changes where you want to put the solar panels again. Just something we have to work around with net zero in existing communities. So that air source heat pump does have a backup. There's electric resistance that will kick in the fan in the air source heat pump automatically, and it's modulating. So it sees the declining performance of the heat pump system and then starts to top up with electrical. It made it very tight to fit this on the existing panel because we didn't upgrade the meter. But it fit. We made some improvements by going to a condensing dryer, which opens up some amps, right? And you're kind of juggling that around. But in Calgary, you'll see all heat pumps have some type of secondary system to support the house in very cold temperatures. And that's normal. We don't really call it a backup system. It's not redundant. It's not a backup per se, but and building code doesn't define backup. The building code just defines multiple heating systems. You have to have multiple heating systems that can meet the capacity loads of the home. And so you basically have a primary and a secondary type system. The heat pump will pump for as long as it can at the most efficient. Then you can switch to straight electric. We assessed whether the backup system should still be natural gas. but the homeowners didn't like that idea of keeping the connection. And when we ran the financial numbers, keeping the natural gas just for such a small load was really a negative financial impact. Cutting the gas line was a huge amount of cost savings that we reinvest into the electrical side much more effectively. So, this is a much simpler house, but one of the more complicated areas was the bay window that had been added in the 80s on the back, made a tight area. So we had to do quite a bit of roof reframing to make the eaves work, give us the clearance that we needed for the new foam, because it was quite thick, 8 inches of new EPS foam with an acrylic stucco. That does change your eave line quite a bit. This house uses an exterior liquid applied air barrier against the original sheathing, and that provided a really nice continuity. It was very easy to install that kind of over all the existing conditions, and provides us a really robust air barrier and protection for the house, so that there's a drainage plane and then the foam is adhered and adds that insulation and water protection. You can go ahead. So when we started, before we took all the walls off and everything, we did do the blower door test. It was 134 gigajoules, so very close to project one, and higher than as if you had built this to new code. You can see that huge space heating load. This one was even worse because it was bigger. It was more complicated than my house. Had a huge space heating load. Those few remaining aluminum slider windows were pretty bad on the Energy Pi. You can go ahead on the next slide. So similar to our house, comfort was a huge piece of this. Fixing the envelope to make the house more comfortable, with an eye to costs and carbon savings as well. That idea of getting rid of the gas line featured really prominently here. Figuring out the best way to get future solar and plan for that availability. But again, we had to have lots of conversations about what do we do about the trees? What are the best roof faces, given that the trees are there for now? Whether we should cut down the trees. These types of things had to be discussed a couple times as you went through the project and tried to find the best pathway forward. There was some upgrades to be done. We found there was some bad plumbing that needed to be fixed, and that created an opportunity for a drain water heat recovery pipe. The kitchen needed a facelift. That was a big part of the driver for the reno that wasn't an energy question. We just need a new kitchen. Well, if we're going to do a kitchen, let's have a nicer rear door with more glass. How do we integrate that? We can fix the non-venting range hood and some other best practice ventilation pieces. This family, was more interested in an aesthetic that gave that nice, clean, kind of modern European style that lended itself to acrylic stucco. They didn't want the look of siding. They didn't want lap siding style. So that's great. You move to an EFIS system, you have a nice, clean, contemporary look. And here they were okay with the windows deep set. They wanted to show off the thickness on the outside and use flashing sills to direct the water away. And it gives the house a really neat look. And you can see from the outside that it's got a lot of insulation on it. It gives it that kind of European look. That's very cool. And it didn't affect the interior as much. Normal sills, more normal trim on the inside of the house. We did find EFIS was a pretty good approach. It's one of our most cost-effective wall systems. The labor costs are relatively good, and you can cover the large area of the house quite quickly. Most of the cost is in the labor of installing it and the materials to coat it. It's not the insulation itself. So when you do the numbers, whether you do 2 inches or you do 8 inches, you do 4 inches, you might as well go to 8. That's not where the cost lie. That was like, $1,000 extra or something in insulation. So it was a no-brainer to go as thick as we could and get a really good R value here. Yeah, so again, that PV system was just the importance of that initial assessment. Putting the roof on the southwest looked like it was going to be really good. Looked like we were going to clear enough of the shading, but these big trees in the existing neighborhood can be worse than you think. without doing an actual 3D study. And so you really need to get to that point where you do a 3D solar study, usually done by the solar installer to help dial that in. It's amazing what they can do. Half hour with a drone, you've got amazing data on what's going to be the best way to handle the house. You can go ahead. Next slide. Um, this project did have the budget to do the whole envelope. So it was important that we got full control of the air tightness. We were going to redo the roof. We put new metal roofing on. Let's do everything right. And so the approach here was to what we call flash and bat. So 2 inches of foam is laid down in the roof and you seal over all the old wires and all the pots and plugs. And we sealed the drywall to connect ceiling drywall to outside wall connection with foam as well. So you're getting high insulation value right there at the eave of the house. And then you come back and you blow the rest of the insulation more normal, blown cellulose, could be blown fiberglass to top up the rest of that R value. Because obviously spray foam is very expensive per inch per R value. So we only use the 2 inches for air sealing, really, vapor tightness, and then fill the rest up as much as we could. So we got about we got about 24 inches of insulation here. It obviously gets compressed a little bit as you get to the edge of the roof. It's a low slope roof. And access isn't great in this low space. It is definitely a challenge to work in these areas. But it did make a big effect because they got the best air tightness at the end of all three projects. You go ahead, Dean. So here they're applying the EFIS. So you can see the big foam blocks that get a cementitious adhesive applied to them that also gives a drainage plane, right? It's got those little grooves to help water if it ever got behind. They all get fit in place and cover over any electrical, and you reinforce areas you need with special fiberglass adhesive strips so you don't get micro cracking and things like that. But again, your primary line of water protection is that liquid applied behind the foam. So you're safe from a water standpoint. You can go ahead to the next, but it is still quite labor intensive. You got to fit all the blocks around, and then you got to top coat and track coat and all that kind of stuff. Still get some nice window sills here. The basement obviously has a deep set window, but by putting the window in the middle of the wall, now you're kind of an ideal thermal position. You get that nice look from the outside of the house with the deep set windows as well. Go ahead. So because we had the crawl space here, this was an opportunity to move the furnace out of the mechanical room that was kind of in the way and pull it in here to the crawl space and still connect to the existing ductwork. So that worked quite well and opened up some floor area. We got rid of the original chimney. That saves another 8 square feet of floor area that you open up for storage or for shelves. And then you have the air source heat pump sitting outside, providing the heat and cooling. Here you can see we took this shot in the fall. That ice layer is starting to build up. So when you have an air source heat pump, you have to plan for that ice. So here we've got a nice wide side yard where that ice can build up when we lift the air source heat pump off the ground. So it doesn't get impacted by ice. And this just melts in the spring and waters the trees nearby it. It's kind of a good water storage system that way. And we don't have walking on this side of the house or concrete or anything like that. So it works well. So we also were able to fit the HRV into the crawl space close to the new fan coil and bent them through the wall in that foam. So that worked out well, improved the ventilation substantially. And then the hot water system changes to a heat pump hot water tank. This does stay in the laundry room, and there's a bit of a synergy there, right? Because you have a condensing hot water or dryer, which is releasing a lot of moisture and warmth, and the hot water, the heat pump hot water tank can pick up that moisture, pick up that heat, and inject it back into the hot water. So that is kind of a nice synergy, I guess. We did notice that this heat pump's a little bit louder. So until the doors were on the mechanical room and everything was buttoned up properly, it was a little louder than the homeowners were expecting. And that's something to keep in mind when you're planning these systems out, is making sure you have a proper mechanical room with walls, maybe some sound insulation if you're going to go with these systems, because they have a fan that runs quite a bit. There's a pump in there like an old freezer. and it's going to be louder than your typical tank that's almost silent. Because we were replacing the stack that had failed in this house, we had a really nice opportunity to install a drain water heat recovery pipe. So this was provided by EcoDrain, thermal drain, and it's a big chunk of copper, so you don't want to get it stolen. New home builders are having problems with these things walking off site, but if a reno is perfect because you're never really exposed to security the same way. It installs quickly into the existing stack with these flexible couplings, and then you provide the cold water supply to the bottom of the coil, and then the top of the coil is now been preheated by that draining hot water, and you send that back to the tank. So the domestic hot water tank is seeing warmer water in to be heated, and that makes a big difference to how quickly it recovers, how much capacity it has for hot water. And so it's a nice synergy with an air source, with a heat pump hot water tank, to have a drain water heat recovery pipe. And then it provides another 3 to 6 gigajoules in energy savings, depending on how many showers you attach to it. So here we just have one shower for the family, runs through this pipe. But it's a nice short run to the tank, and was pretty easy to install. Go ahead. So you're seeing the final look of the house. Got it down to 49 gigajoules, so a much bigger impact on gigajoules when you do that whole envelope. That's what I missed by not being able to do the roof and attic insulation, and not hitting my air tightness target. And this project was allowed to go a lot further. At 49 gigajoules, it's really in range of net zero. So we call it net zero ready. There's enough roof area, potentially on this roof and then the garage roof, that they need to change to kind of reach net zero if they want to in the future. And the plan is, once the cost of this reno have wound down, the solar panels will go on next. So the costs for this project are higher. Obviously, there's a much bigger scope here, 131,000 before the contractor fee. And this one includes the contractor fees, sorry, and GST that was baked into our cost study on the invoices and such that we got. So you see still big cost in the window doors and the wall insulation. These are still the biggest chunks of the cost pie. With mechanicals coming in quickly behind, and some extra miscellaneous work. The ceiling actually wasn't bad at 13,000. Foundation not too bad, 11,000. This case, forgot to mention that we hydrovac'd around the house and installed the 4 inches of insulation around the perimeter. It was fairly easy to do. We had good soils for that, but it's very much site dependent on whether that works or not. I think.
Okay, thank you, Tyler. Appreciate it. I guess on that note, Ben, are you addressing a comment that people might have not been able to see some slides?
Yeah, Karen, you commented you can't see the slides advance, and it looks like they are coming through on the other end. So it might, if anyone else is having issues seeing the slides advancing, drop a note in the chat there and let us know. Otherwise, from what I can see, we're logged in on a separate device here locally, and it looks like they're advancing on our end. So Karen, it looks like it might be a connection issue on your end.
We got a question there from Lee on the PV plan for the roof. The nice part about a metal roof is there's lots of manufacturers that build little standoff clips that make it very easy to run the rails and put panels wherever you want. It gives you really flexible potentials there, and we don't have to impact the roof again when we come back to do solar in the future. So it should work out well. You just have to get the right clamp for your profile of roof, and you just go to the catalog and make sure you've got the right clamp. And we've started planning that out with the solar installer when they're ready. I think there's a little bit more electrical work to do when they prepare for the solar, because we did max out, and we're kind of waiting also on a decision about what to do with the garage in the back, because it is quite old and we do want to put panels on it. So you got to decide, are we fixing the garage now? Are we going to do the garage and put solar on it and then rerun electrical and stuff around? Because what would likely happen is if you redid the garage, you'd want to move the electrical to the garage, so you don't have this overhead line running across the backyard, and so that will impact a little bit on how we prepare for solar, and it's tied up in that old garage. But again, you start to run out of budget, and well, maybe we can defer the garage for a couple of years, pay off a chunk of this, and settle in, and then come back and do it. So that's kind of the plan. We have a plan for how that'll work, and that allowed us to leave the kind of electrical infrastructure of the house alone for now, with a plan on how we'll upgrade it in the future. And we'll see. Project 3, Steve's house, did move the electrical to the garage and made a nice difference in the backyard, set him up well for the net zero stuff that he did. So, that's kind of the approach we're reserving. It is a standing seam metal roof with the little locks on it.
Awesome. Thank you, Tyler. If there's no other questions at this moment, we'll maybe take a quick break, just a quick 2-minute break. And then Steve will join us and discuss his project. And ideally, there's a little bit of time at the end if there's any further questions or overall questions or some overarching, and or maybe a bit of time for discussion. So with that, I'm just going to pause it here, and we'll see you back here in a couple of minutes. All right, everyone, welcome back. We're gonna listen to Steve Norris here, so how about it?
Thanks, Dean. Hope you all took the advantage to get up and stretch, move around a little bit. Ben's watching the chat box, so if you can't hear me good enough or have any technical difficulties, let me know right away. Otherwise, let's go. So I want to talk a little bit first about just coming back to the roadmap that I assume you guys did a lot of discussion on during this week. Super important part of the process. Assessing things from the beginning, asking the right questions, and having a good planning process is super key in these types of projects. Otherwise, you end up just doing way too much guessing and exploring. So really important to start with those good assessments up front, knowing what your client wants and what their goals are. And sometimes that takes a little bit of digging just with clients to know if they're on the same page, if it's a couple or a family, and really figuring out what those goals are up front. So this is my house. It was the simplest structure of the three, so it was kind of that most ideal case. I'm also the homeowner and the contractor, so a lot of decisions were really easy to make up front, which isn't always the case. I was committed to a certain path to get to net zero, and I also wanted to finance it in a single stage, which made a lot of things easier. So looking at deep energy retrofits, the first question that I think everyone should ask as part of that assessment phase is, should we do this? If you're not planning to live in that home for a long period of time, or it could get demolished in a short period of time, it's not worth investing the money or the carbon. So we don't really want to get into projects that are actually, working backwards as far as our environmental goals. So in this case, I have a pretty good scenario: 1955 single family bungalow, simple structure, suite, garage, studio. And we were really future-proofing an existing family home for ourselves. We made the decision to stay there for a long time. We have my wife's art studio in the garage. We have a legal basement suite in the basement. So a lot of those things have really made the structure and the home worth investing in long-term. We did have some additional goals. We wanted to improve the thermal comfort and durability. Got a little hot in the summertime, some cold spots throughout the home, and just not having to spend more money on it down the road as far as resilience. We wanted to get to net zero with on-site energy. So we did our energy modeling early and looked at our potential solar production, and we're basically aiming at the reduction in heating load primarily that we needed to hit to get to net zero. And one of the other goals was to use cost-effective, locally available materials with simple construction. So you'll see in the pictures later that we used a Larson truss approach with blown-in cellulose. So really good environmentally conscious materials, and also basic building products, 2x4s, plywood, super easy. I wanted to avoid foam products as much as possible. That's kind of a personal choice, and weren't always able to do that. So that's one of those compromises sometimes. We did have some other design consideration. We have pretty good overhangs on the house with room to add thickness, so we didn't have to extend any roof lines like Tyler did. So that added a lot of simplicity. And this project, that Larson truss outrigger, was also the best bang for our buck. So looking at the project, here's the summary. The advantage of doing a retrofit like this in a single shot, one of the big ones is that you can eliminate a lot of penetrations. So you might see some photos later where we reduced a lot of penetrations through our attic and through our roof. So we had 2 chimneys, we had 2 bath fans that were able to be removed, a bunch of ceiling penetrations. So we really only have 1 penetration going out our ceiling and roof, and that's the kitchen exhaust fan, which we wanted to keep that so that we're not drawing grease into our ERV. And also because the ERV simply just doesn't have enough capacity to draw out, say, smoke when you're cooking. And when you do a lot of heavy cooking, it needs a higher CFM capacity. Some of the other things, the wall insulation, we had, original 1955 walls with very little insulation. A little bit of extra R20 in the addition to the house, which was done by the previous owners in the 80s. And we want to get all those walls up to, as close to that R40 mark as we can. So with the original walls plus another approximately R30 in that Larson truss, we get to almost to that R40 level. In the ceiling, we blew in 17 inches. So getting to that R60, we had in the meantime to remove all the wood chip and fiberglass, which was a bit of a messy vacuum job. And then I crawled around up there for a couple of days, just manually air sealing those things because I didn't want to do the flash and bat with spray foam. In retrospect, I don't know if that was the right decision. I wasn't able to hit the air tightness goals that I had. So I've been looking into some other options, like just a spray down air and vapor barrier that's not a foam-based product. I did end up insulating the exposed area of my foundation. You'll see some pictures on that later, and did replace all the windows and doors. I did try to keep a couple original dual glaze windows, but they ended up frosting up right away. So I kind of ordered some new windows in a panic and swapped those ones out. We had original natural gas furnace and bath fans, which we cut out all those fans from the ceilings and just used our ERV connection to the bathrooms. Replace that natural gas furnace with an air source heat pump and interior fan coil with electric backup. We also have a heat pump hot water tank. We did increase our electrical service to 200 amps, and there was a minimal upcharge for that because there was room on our local transformer. And then we knew up front that our solar capacity was going to be about 50 kilowatts, and we were able to hit that target. You can see we increased our annual electricity consumption, but eliminated our gas completely and decreased our heating demand by about 77%. We do have cooling, which is a nice little bonus. Our air leakage rate, we didn't get it down quite as much as I had hoped, and I think that's primarily because of that attic condition. So here's some original condition pictures. Simple structures, single family bungalow. You can see in the top right there, we had some freeze windows that froze up on a regular basis. We get a good ½ inch of ice on those back bay windows. So we actually reframed that whole back wall flat. So we didn't have that kind of projection that was always cold in that part of the house. One of the things to consider when you're doing a retrofit is other things that you have to pull apart, like decks. Because we wanted to air seal and insulate the rim all the way around the house where all of our floor joists come to, you often end up having to remove a lot of those structures that may be ledgered or built onto the exterior of the house. The front step, you can see in the middle of the top, you can barely see it, but concrete front step, which we had to break that apart. Here's the original energy model, 152 gigajoules a year, and you can see space heating is most of that load. Here's some demolition pictures, removing that the deck off the back. We had some layers of siding that had to be removed. So there's quite an extensive demolition process, which we were trying to minimize at the beginning, and then realized partway through, you know what, let's just keep going. And by the time we removed, stucco around from all those windows, you might as well keep going, start with a fresh, clean slate where you can see if there's any deficiencies in the original plywood or lap sheeting, whatever that existing condition is. So don't underestimate the demolition. One of the trickiest things in a retrofit, if you're not pulling your roof off, is the connection of your air barrier from attic to wall. And because I wasn't spray foaming the attic, I needed to somehow make that connection in a very small space, especially at the top of wall, where in my case, it's bird's mouth construction. So you only have about 2.5 inches to insulate. So that can become kind of the weak spot in your envelope. So what we did in this case is we nailed a strip of plywood to the underside of those ceiling joists. And then we spray foamed up onto the top plate and onto that plywood, and then ended up caulking our air weather barrier onto that plywood strip. Here's a picture of the roof venting. Now, all of these things are not coming through my ceiling. These are vents. So what we did was we added vents down low, right at the top of where my new insulation is. And that's where the draw for ventilation is. And then it exhausts out the top of the. Here's all the manual air sealing in the attic, which was a real pain. So there are better ways to do this that I should have taken advantage of. Here's a couple of the chimneys that needed to be removed, which was fantastic. A lot of demolition if you're electrifying, because there's things like fireplaces and chimneys that need to be removed and air sealed. And here's kind of the star of the show with our Larson truss on the exterior. So you can see that on the sheeting layer, what we've done is added a 2x2, which was actually just a ripped in half 2x4. And then we added 3 plywood gussets pre-cut at top, middle, and bottom. And then we used the outside 2x2 when we nailed that on to be able to level it up, because with existing construction, you're never dealing with square walls. So that gives us the chance to square it up before proceeding. You can't see it really well, but at the bottom, we basically caulked a strip of Typar as well to the concrete foundation that wraps up and over that bottom 2x2. Here's the mesh. And then you can see on the right, the installation of the dense packed cellulose. They just cut a little hole at the bottom, fill it up, cut a little hole at the top, and fill it up as well too. And it's to a pressure of, I believe it's about 4 pounds per square foot. And basically it billows it out so that it doesn't settle over time. So you actually, sometimes you can see on the left, they have a little roller. If it billows too much, they'll roll over that, especially if you're doing an interior application where you have to drive all over it. On the right hand, you can see the Typar starting to be installed over top of that layer. And then here's Corey tape sealing that Typar layer onto the windows. So we also have that exterior air barrier, so sealed everywhere. There's that back wall where we had cut out the bay window and added it with more window, but horizontal. So it's a little bit more protected from the weather, but still gives us that same kind of panoramic view of the backyard. Here's the double strapping layer. Our siding was a vertical corrugated metal, so we needed to finish with horizontal strapping. So we did vertical first, then horizontal. The advantage of that is the screws that we use to install our metal siding doesn't penetrate our Typar layer. It's just embedded in that horizontal strapping layer. One of the hardest parts of this retrofit was the crawl space. Pretty tiny, only accessible from the exterior, and full of mice and wasp nest, and it was pretty nasty down there. So we ripped off all that skirting, and there's actually, mouse leavings within the insulation of the heat runs that leave our concrete foundation and run under that space. So it was good to kind of clean that all up and get it air sealed from underneath, which was a little tricky. On the left, you can see me, I had a little wheelie that I could only use in one part of that was tall enough to move around. So I spent a few miserable days down there trying to replace insulation and air seal that as much as I can. And it probably finished up maybe an 8 out of 10. Pretty hard to do a good job of that in that kind of space. There's that air sealing. Even trying to air seal the gap between beams was difficult. So there's a lot of places for air leakage down there. Here's our heat pump. The original one that was installed was undersized. My mechanical contractor just missed carrying the one in one of his calculations, and we ended up having to replace that. There's also a bit of learning to drive your house. An electrified retrofit house runs differently. So you have to play with it. You have to learn how to use it properly. Sometimes there's some failure errors that you have to deal with. Here's my ERV. On the top left, you can see it installed in our mechanical room downstairs. It draws from our bathrooms and then draws the heat and energy off of that and supplies it to our fan coil before moving throughout the house. You can see in the top right, one of the difficulties or trickiest parts of adding ERV in an existing home is those runs to the bathrooms upstairs. Even worse in a 2-story house, let alone a bungalow. So there are a couple of places where I had to build extra bulkheads after the fact. And here's the finished product. So you can see I didn't mention it, but we did the garage at the same time. I just added 2 inches of mineral fiber on the exterior of the garage. Did put a little heat pump in there, and then we have solar on that one as well too. So it's a nice studio space. Our house has pretty good solar exposure. It actually, the corner of the house faces south, so we have southeast and southwest power. So we use a lot of that power in the mornings and evenings where you're at home using the most of your electricity as well too. You can see on the right-hand picture, we did move our electrical service to the garage. So on the right-hand side, you can see our new low voltage and power there. We dug a trench underground to the house. Another picture from the front and the back. Here's kind of the final deal. We are actually net positive, and we'll be able to substantiate it after a year. But the way that our consumption is looking right now will be positive over the year with our solar system. You can see that space heating is still a big component, but much smaller. And it's interesting to see that if you look at number F, the other electrical, now all those residual things that you weren't really counting before become a bigger piece of the puzzle. So that's part of driving your house and learning what those extra loads are. Here's the quick budget breakdown. Our project was about 135,000, not including contractor fees, a little bit more expensive, but a pretty big scope with the electrification as well too. So it's really difficult to substantiate kind of the incremental cost of some of these upgrades, because there's such an overlap between things we just did because we wanted to, and we were renovating. So replacing windows, replacing siding, replacing shingles. But then if you look at the incremental cost of better windows and buying some electric appliances, it's a small piece of the puzzle. So kind of that sweet spot for renovations and retrofits is overlapping work that you're going to do already with taking advantage of that opportunity and working on the energy improvement of the house. Just to bring it back to the roadmap, that assessment phase was certainly key. We knew what our goals were, so we were able to work in that direction right from the start.
I think, Tyler, you're going to speak to this a little bit at the end here. We kind of were able to crunch some numbers across these 3 projects and how the savings compared to the upfront cost. So Tyler, you can speak to this a bit more.
Yeah, this is, graphing out how they broke out compared to the first year energy savings. So this is just looking at kilowatt hours and monthly costs. And we like to talk about it in terms of return on investment. You can talk about payback periods and other metrics as well. This is just one of the simplest ones. But what we really saw is that, from a financial standpoint, going all the way, getting those solar panels on is really important from a financial standpoint. That's really where your cost lies in the electricity, and going all the way to net zero, make that work out the best. It's not an amazing ROI. 2.9% is probably not as good as your mutual funds and your retirement plan. But it's not nothing. And I think that's important, that this is a better ROI than lots of other things we spend our money on, like cars and vacations and granite countertops. And it's reasonable. And that it's better the further you go, especially with that solar piece of it. Yeah. You have to factor in that some of those costs were baked in. You had to replace the windows, you had to replace the siding anyway because they were at end of life, or you had to replace the mechanical system because it was at end of life. So how do you factor that into the ROI? You really need to take away some of those costs as sunk into the house as part of maintenance anyway. When we look at the houses from a carbon standpoint, the interesting thing that happens is that all that energy efficiency that we put in doesn't actually save that much carbon, because you're saving natural gas, which in Alberta is our low carbon fuel. Electricity is our high carbon fuel, and that's opposite for most of the country. So project 1 and project 2 don't have amazing carbon savings, until that solar is all added. Whereas project 3 really has the great carbon savings and maximizes that solar substantially.
Awesome. So that kind of concludes going through these 3 case studies. And again, to bring everyone back, those who haven't had a chance to use this link and download our deep energy retrofit guide, which is a great companion to the webinar series we've gone through this week. I'll just leave this slide up here as we go through a couple questions here. Steve O says, what is everyone's thought on chainsaw retrofits and unvented conditioned attic with a vented over roof? I think Steve and Tyler might weigh in a bit on this. I think for some projects it can be a great solution. It kind of goes to what's the geometry of the home you're starting with and what are the goals through the retrofit, especially if you're looking at an existing home with a traditional attic and converting that into using the attic space. It can be quite a undertaking to do that, but it kind of fits in with what you want to do in the condition of the house. And there are some homes that are going to be an existing cathedral ceiling, kind of similar good condition to run with on that as it goes. Chainsaw retrofit is a great option for many homes to look at.
We debated it in this project for sure. Sorry, Steve.
That's good.
But I was going to add that Corey, who did the framing on the houses, and Peter, who worked on project 2, have both gone on to do chainsaw retrofits on future projects when it was the right approach and it matched the architecture and the project goals. There's definite advantages there. In our project study, it really showed a cost implication, not as good a cost picture. So it really depends on the house. Sorry, Steve.
No, that's okay. Yeah, I really like the idea of the chainsaw retrofit where you're able to, tie that insulation and envelope layer from your roof down onto the walls. One of the disadvantages of that is you lose the overhangs on your house unless you're rebuilding them. So then you end up with, framing and finishing costs that are additional. So the weakness in my envelope is that, that 2.5 inches at the top of the wall, that is all I can get for insulation. So I could have improved that with a chainsaw retrofit, but then I lose that nice deep overhang that's protecting all my windows, shading my windows in the summertime. And I have some amazing pictures when it rains at my house, the perimeter around my foundation is bone dry, like even in a hard driving rain. So I realize how much those overhangs really protect the house from weather.
Yeah, and I think that's one thing we really need to keep in mind too with these retrofits. It's not just for the energy savings that we do them and for electrifying or comfort, but it's also an opportunity to improve the durability of the home. So having those overhangs or kind of that wide brimmed hat on our home is probably one of the easiest long-term methods to ensure resilience against water intrusion in a system. So when you remove those overhangs, as Steve said, you can either reframe them as part of the project, but then that's how is that penetrating the air control layer, or you leave them off and you're increasing your potential for water intrusion at windows and other penetrations.
I think too, you have to factor in if you're planning to do an interior reno, you want to drop your ceiling and you want the vaulted ceilings and you're prepared for that mess and that disruption, then a chainsaw reno insulation on top of the roof makes a ton of sense. But in project 2, we had a beautiful stucco ceiling, stipple ceiling from 1957. We didn't want to lose that. So there was less incentive to heat the attic space, and because we couldn't vault it, we couldn't pop up into it everywhere. And whereas another project has beautiful open rafters now and the space feels huge because you could do the chainsaw retrofit and got the ceiling, vault everything, and it's really cool. So very project specific.
Yeah, awesome. So other question here, how do you deal with the kitchen and dryer exhaust and deep energy retrofit? Sounds like you connected the bathroom exhaust to the ERV. Can you do that with kitchen and dryer exhaust? I'm thinking grease and lint would wreck the ERV. One thing we did not touch on in recounting these case studies, I believe all of these, we changed the dryer type to a condensing or heat pump dryer So there's no more venting of that drier air outside. That's one of the things we touched on in electrification on Monday. Is that there are great options which are very similar cost to standard dryers and even washer dryers for a heat pump dryer or a condensing dryer or an all-in-one condensing washer and dryer as well, which are significantly lower energy use to a traditional dryer, and then you don't have to worry about that vent and managing that through the house. Yeah.
Did you want to add anything to that, Steve, with your kind of goal of kind of removing the air penetrations through your attic?
Yeah.
What was some of the products you were testing from Passive House and what have you?
Yeah, I mean, Ben answered it right with the dryer. I have no more dryer penetration. The kitchen exhaust, you can eliminate your kitchen exhaust penetration if you want. There's a couple of requirements to that. One is that you have a good grease filter on whatever range hood or charcoal filter or over the range microwave that you have. That's going to take some of that. And you also need to put your ERV draw from the kitchen area far enough away from your cooking surface that it's not going to get those kinds of things drawn into it. So I forget what the distance is. It's
about 1.5 meters, I think.
Something like that. So one of the things that I've seen done is to put that draw behind the fridge, where you're actually drawing the heat away from the back of the fridge, which is good for the fridge itself.
Right.
And then it also gives it a bit of protection and barrier away from drawing in some of those things from cooking as well. The reason I decided to keep my kitchen exhaust and not go down that route was just, I was planning to install 100 CFM ERV. So when that thing kicks into high gear, I'm really only drawing 33 CFMs from the bathrooms that it's drawing from. So there's very little capacity left if I was to connect also my kitchen exhaust to that, whereas I get a lot more CFMs, a lot faster draw off of my exhaust fan right now.
And
I did the same thing. Sorry. I did the same thing at our house. We kept the exhausting range hood going directly outside because we wanted that quality of exhaust. We wanted the really effective exhaust. That was worth it from an air quality standpoint for us. But we also put an HRV intake 1.5 meters away up at the ceiling level to catch what the range hood misses or to catch that general circulation. I think that works really well together. And we've noticed it in cooking, right? When I make butter chicken, the whole neighborhood knows that I'm making butter chicken. Nobody else in the house does.
Yeah. Cool. And with those exhaust hoods that you're still pumping outside with your more airtight homes, some more airtight than others, are they digitally connected to the ERVs, or is there a makeup air component that you have integrated with those at all?
No, I mean, mine was existing, so I kind of didn't mess with it. You can tie those things together, but not in this case. And then, I mean, there are ways to put in higher quality dampers as well too. But just kind of left what is there. So it has a traditional damper that, closes that to its best ability.
You don't have to worry about the makeup air here because we didn't put in big range hoods. As soon as you're under 150 CFM, the building code is less worried about the depressurization, even under the new B300 standard, which looks at exhaust depressurization. Once you get in over 300 CFM, then you're watching really closely. We also don't have any combustion equipment in Steve's house, and we have sealed combustion in my house, no combustion in Project 2. So the risk of depressurization is super low. So we're not worried about having those exhaust fans without makeup air.
Yeah. And I guess too, really quick, when we're switching to an electric cooktop, we don't really need those higher rates of ventilation from a range hood as you would with a gas cooktop.
Yeah, it's more for what you're burning while you're cooking.
If you're making butter chicken or Jamaican jerk fish or something like that, and you want that good capture hood, right? It's really about more effective ventilation than quantity of air you pull out, right? If you can capture it all and get it out of the house, that's what you want. That's the real lift.
I don't know about you, but I do want to test out Tyler's butter chicken now, since he seems to be bragging about it.
Yeah.
So, okay, so I see that we're just over our time here. So I want to first off to say thank you to Steve and Tyler for joining us today. This has been actually really fantastic. And ideally, this topic I'd like to kind of close this out by kind of having an overarching question or have a quick final thoughts on where retrofits, this, from my standpoint, the topic of retrofits has only accelerated in the last handful of years. So you're on the ground, you're in the thick of it. Tyler, you're working hard and energy advising for a project like this. Where does this industry go? How is this the right solution? What are the high level, if it always comes down to budget and we have certain incentive programs that are kind of piecemealing it and whatnot, what is the truth and the background, basis to really making a difference here, and or as far as the retrofit topic goes? Stephen, maybe I'll let you go first.
Oh boy. That's a great question, because I work in multifamily construction as well too, and actually did a talk last night at a builder event on making the case for passive house and high energy efficiency in the multifamily world, which is really building multifamily is inherently more sustainable than single family, where we have existing homes for one family with a large envelope, a large heating load. So we're really in a transitional period, from houses that were built in the past to where Calgary is going in the future, which, single family housing is going to go away. But the fact is, it's still here right now. And if, my viewpoint is, if you're going to stay in your house and it's worth investing in for at least 20 years, in my mind, that's kind of the breaking point. If this house is going to be, demolished or substantially renovated in any less time than that, it's probably not worth it. So there are homes in Calgary that are worth doing, and there are some that aren't. In some cases, it's better to just, allow things to proceed and have houses get demolished and rebuilt into multifamily.
Yeah, it's a sad reality, I think, but I cringe at the day that somebody with a house, a little bungalow down in Sunnyside or Inglewood or something comes to us and say, I'd like to do a deep energy retrofit on this house. I'm like, man, I'd really like to put a triplex on this lot and make it net zero. And that's really going to have a bigger impact on carbon and a bigger impact on energy savings by densifying and making energy efficient the housing that's there, rather than carrying older homes that maybe have run their service life in an inner city context. But there's a lot of homes that do need to be retrofitted. I think what has me most excited though is multifamily sites like Steve's talking about. When you think of the amount of housing stock we have in Alberta of purpose-built rentals and condominiumized townhouses in groups and developments of 100 and 200 units that are right at the age of replacement. They are making the decision about whether it's time to invest, and they got to do the roof and these kind of things. Our initial numbers are showing developments like that, where you get a repetition of design, you get a concentration of work in the scale, and it makes the cost of going to net zero per unit way better, and the potential where it becomes a financial no-brainer, where the ROI is so good that why wouldn't you? And so I think that's really what we need to focus on next is how do you do this on multifamily housing, and trying to find the right incentives for larger landowners, the Boardwalks and the Mintos of the world, to really get serious about redeveloping, refreshing the existing rental stock they have, because we can shave. And that's where affordability really matters, right? Is in the rental market of these townhomes, where you're often paying utilities yourself in a tight rental price on top of. And here's a chance to take the energy cost to nothing for these homeowners, for these home renters, and at a really smart scale, I think, because the reality is these single family deep energy retrofits, they're very cool and there's a market for them. There's no question there. And there's homeowners that will get great benefit and great use out of these, but they're limited to homeowners that have the budget and have the right house. And we need more than that. We need to talk about thousands of units. And to do that, it's going to be in the townhouse market, I think, where we want to focus.
Awesome. Great. Okay. Do you have anything else to say?
No, Echoing Dean, thanks everyone for joining us this week as well, especially those who, several of you have been here every day of the week, drinking in the knowledge. We hope it's of value to you.
These have been recorded, correct?
Yes, these have been recorded, so likely earlier in the new year, we should have these available on YouTube for viewing and sharing to a larger audience. So those who weren't able to make it to every session this week, we recognize everyone's busy. There's lots of things going on in the future. These will be available so you can catch up.
Awesome. Okay, with that, thank you again, Tyler. Thanks, Steve. We'll close out and
Thanks, guys.
see you guys again.
All right, have a good one.